Hello everyone, today we'll talk about tools and methods for assessing, recovering and data-limited stocks using an example of recovering stocks in Lithuanian freshwater ecosystem. The main author of this paper is Eglė Jakubavičiūtė. I'm a senior author, Asta Audzijonyte. I'm substituting for Eglė for now. So there has been a few suggestions that a lot of stock assessment tools have been developed actually for depleted stocks, and therefore as the stocks are recovering we are going to face some challenges in terms of change and growth due to density dependence of these stocks. So many of these questions and assumptions are not easy to test in marine ecosystems, but in Lithuania we have an interesting situation and a very useful situation where we have two populations. One is in the Gorfine lagoon, which is shared with Russia, a large productive water body where commercial fishing is quite intense, and also in the Kaunas reservoir, which has been built in 1959, where all commercial fishing has been banned in about 8 years ago, and since then some stocks have been undergoing very rapid recovery. Main species in these ecosystems are pike perch, roach, bream and perch, a common freshwater species, and they actually show very different responses to the ban of commercial fishing in Kaunas water reservoir. So we look, for example, at these four species. We see that roach has actually shown an amazing recovery, and we will go to this estimation a bit later. But even if we look at the distribution of size frequencies since the ban of commercial fishing, we see a rapid increase in size, in body size in these populations. These are annual size frequencies through time. In other species, the situation is actually quite different. There hasn't been much evidence of recovery in perch, where neither size frequencies nor model estimates show much improvement in the stock status. In bream and pike perch, there is evidence for small recovery in the last few years, but yet it is not as strong as it is in roach. So one of the questions for these different rates of recovery in different species is whether it has anything to do with the density dependence. And for data-limited stocks, for example, where we don't have age data and we use some surplus production-based models, which are based on catch per unit effort series, there are two ways to include density dependence. We can assume either the Schaffer or the Fox model, which makes different assumptions about the maximum production of the stock relative to the maximum biomass. So the Fox model, which is used quite often, actually assumes that the stock is more productive at its biomass that is lower than half of the maximum biomass, whereas the Schaffer model assumes that it's about half of the biomass that produces the highest surplus production. So we try to apply these surplus production-based models in Java and MQMF produced by different authors, using input of standardized scientific monitoring catch per unit series, where we account for season, gear type, gear length, and a series of commercial catches. We applied these models for all the species, but here we show only roach, results with roach. Basically, as expected, we find that the Fox model and Schaffer model give slightly different results. Schaffer model infers that the depletion level was higher than with Fox model. We get slightly different estimates of population parameters, and also Fox model suggests that the population is about reaching the maximum capacity, and its actually growth rate is expected to go down. We have 2 more years of data now, which we can present at the conference and see which of these two estimates fits the data better. However, it seems that for a recovered stock, alternative Schaffer or Fox density dependence assumptions do not actually make much difference. So how about a depleted stock? We do actually have a very depleted stock, which is a pike perch in the Gorfine lagoon, and we applied both models, Schaffer and Fox, and the green line is the Schaffer-based model, which fits the data much better than the Fox-based model. And the inferences are quite different from these two models. if we, for example, look at the estimated R, K, or MSY, or harvest level, they are massively different between these two models. By the way, this is the Shiny R application of the surplus-based production model, which will soon be available through our website for everybody to use. So our conclusion is that in surplus production models, alternative assumptions about stock density dependence can have huge implications for the status of depleted stocks. We haven't had time to go here into size-based models, which generally assumes that growth is considered constant, and it can be a problem. Thank you for listening. For more information, go to our website, and if you have more questions or comments, contact Eglė.